starting with the compressor that creates the flow of refrigerant through the air conditioning system. The compressor is usually driven by the engine using a drive belt, with a magnetic clutch being used to engage and disengage the drive to the compressor. For some systems, a DL pulley is used that continuously drives a variable displacement type compressor, and for electric and hybrid vehicles, the compressors are driven by electric motors. To provide lubrication, a specific amount of special compressor oil is added to the refrigerant. The compressor creates a high pressure at the discharge port and a low pressure at the suction port. The compressor sucks in the gaseous refrigerant from the evaporator, where this superheated refrigerant has absorbed heat from the passenger compartment. The gas is then compressed, which adds additional heat, and the high temperature, high pressure gas is then forced from the compressor discharge port to the condenser. The condenser operates using the same principles as a domestic radiator, because the condenser transfers heat to the air. The condenser is divided into 4 main sections. A gaseous section, to remove the heat from the hot gas, a condensing section, a gas-liquid separator, known as the modulator, and a subcooling section, with the high-pressure refrigerant flowing through these 4 sections in that order. The gaseous condensing and subcooling sections consist of tubes and fins, and, as the refrigerant passes through the gaseous section, the heat contained in the high-temperature refrigerant gas transfers through the fins to the outside air. This loss of heat reduces the gas temperature, which allows the gas to condense within the condensing section, where it naturally changes state to a liquid. The liquid refrigerant then passes to the gas-liquid separator section, where any remaining gas is separated from the liquid, providing further opportunity for the gas to release heat and change to a liquid. The liquid refrigerant then receives additional cooling in the subcooling section, where the heat energy contained in the liquid refrigerant is again released through the condenser fins to the air. This further reduces the temperature and improves the overall cooling performance. The cooled liquid refrigerant flows to the expansion valve, where the high pressure of the refrigerant forces it through a small orifice or hole, and this has the effect of injecting the refrigerant from the orifice as a mist that is then able to expand. The expansion allows the pressure to reduce, which also reduces the temperature, and this causes the refrigerant to again change state from a warm, high-pressure liquid into a cooler, low-pressure mist that is able to more easily absorb heat when it passes through the evaporator. The expansion valve also adjusts the quantity or flow of refrigerant passing to the evaporator. Too little or too much refrigerant results in too little or too much heat being removed from the passenger compartment. Low-pressure mist refrigerant now flows into the last major component of the air conditioning system, the evaporator, which is located within the air conditioning unit. The evaporator consists of a tank, tubing, and fins that are exposed to the air in the passenger compartment. Therefore, heat from the air is able to transfer to the fins, and it is then absorbed into the refrigerant mist. And at the exact moment that the refrigerant absorbs this heat, it vaporizes and changes back to a gas. This superheated gaseous refrigerant then flows from the evaporator and back to the compressor, where the whole process starts again.